Welcome. In this video, we'll introduce you to reflow soldering, an essential process for working with surface mount device, SMD components, like those used in the LCC Fusion Project's PCBs. Reflow soldering involves heating solder paste to a precise temperature, allowing it to melt and form strong, reliable connections between components and the PCB. We'll show you 3 low-cost alternatives to expensive reflow ovens, using a hot air gun, a soldering hot plate, and a countertop oven. We'll discuss the pros and cons of each method, their limitations, and how they can still provide great results for hobbyist-level PCB assembly. For the first method of solder reflow, we'll demonstrate how to use a hot air gun. We'll begin by showing a soldering station equipped with a hot air gun and demonstrating the process of heating a resistor SMD. To perform the reflow, we start by applying solder paste to the SMD pads on the PCB, ensuring the pads are lightly covered. Then, using the hot air gun, we set the temperature above the sawdust melting point, typically around 250 degrees Celsius. We apply heat in a circular motion over the component. As the paste heats up, it will melt and the component will settle into place, creating a solid solder joint. Watch for the solder to turn a clean silver color, with all the gray paste completely melted away. It's crucial to apply a minimal amount of solder paste to pads. Too much paste can cause solder balls to form, which will roll around on the PCB and require additional cleaning. The hot air gun method is ideal for rework, allowing you to add or replace a small number of components on a PCB efficiently. This technique is also helpful for adjusting the position of components that have already been soldered, providing a quick and effective solution for corrections. Now, let's look at the second method of solder reflow using a soldering hot plate. We start by applying the solder paste to the SMD pads on the PCB. After setting the hot plate temperature to around 165 degrees Celsius, we carefully place the PCB in the center of the hot plate. The heat from the hot plate will gradually melt the solder paste, allowing the SMD components to settle into place and form strong solder joints. We monitor the process until the solder melts completely, and we observe the transition from a dull gray to a clean silver color. Once the reflow is complete, we turn off the hot plate and let the PCB slowly cool to ensure solid joints. The advantage of using a hot plate is that it allows all of the PCB's SMD components to be reflowed at once, making the process faster and more efficient. However, this method has some limitations. It cannot be used for reflowing PTH components, as the PCB must lay flat on a hot plate surface. Additionally, the number of PCBs that can be soldered at one time is limited by the size of the hot plate. For the best results, we recommend doing one PCB at a time, centered on the hot plate, where the temperature is most accurate and even. For the third method of solder reflow, we'll use a countertop digital oven, an affordable and effective alternative to a commercial reflow oven. Start by setting the oven to the broil setting, with a temperature of 280 degrees Fahrenheit, around 138 degrees Celsius, and set the timer for 6 minutes. This heating pattern closely matches the temperature requirements for low-temp solder paste, ensuring optimal results. The broil setting is ideal for evenly heating the top of the PCB, allowing multiple PCBs to be reflowed at once. Place the PCB into a cool oven to ensure a proper rise in temperature, preventing thermal shock and allowing the paste to melt evenly. Once the reflow process is complete, open the oven door and let the PCB cool down naturally. Avoid disturbing the PCB for a few minutes to allow the solder joints to solidify properly. One of the advantages of this method is that a typical digital countertop oven costs less than $100, making a much more affordable option compared to a commercial reflow oven. The results can be surprisingly good, making this method a great choice for hobbyists and small-scale projects. Additionally, both SMD and PTH pasted components can be reflowed at the same time, as long as the PCB is suspended properly, ensuring the PTH component leads remain undisturbed. The countertop oven can also be used to reheat a PCB to recover or fix components that need adjustments. Thank you for following along with our solder reflow tutorial. We have explored 3 different methods, using a hot air gun, a soldering hot plate, and a countertop digital oven, to perform reflow soldering on your PCBs. Each method has its own advantages and limitations, and you can choose the one that best suits your needs and budget. For more information on the LCC Fusion project, including PCB assembly instructions and component lists, visit the links below. Don't forget to subscribe, and check out the rest of this channel's videos for more DIY electronics and model train automation tips. Happy soldering!